similarity, we're going to be talking about dilations. Please write down in the dilation box the following definition. A dilation is a transformation that stretches or shrinks a figure to create a similar figure. Okay, so we're either making it larger as an enlargement or reducing it in size. The shape is still staying intact, it's just that the size of it is changing. The center of dilation is a fixed point where a figure is enlarged or reduced with respect to. With respect to. So what it's based off of. For all intents and purposes, your center of dilation will always be the origin. It gets a little bit more complicated when we move your center of dilation to a new ordered pair, because then you have to do a little bit more math to it. So your center of dilation will always be the origin. All right, so we got dilation, we got the center of the dilation. So your scale factor is the ratio of a side length of the image to the corresponding side length of the original figure. So the ratio of a side length of the image to the corresponding side length of the original figure. So just like we've been doing this whole entire course, when we were talking about scale factor for model, we were doing model over actual. When we were talking about scale factor just for similar polygons, we were doing new over the original. Same thing, scale factor for dilation, you're doing the new, which is your image, over the original. Okay? Do you remember what little marking we put next to a ordered pair to show that it is the image when we graph it? A little, yeah, not the star, a little like prime sign, apostrophe, whatever you want to call it. Okay, so let's go ahead and do an actual dilation, huh? It's like an apostrophe next to it. I'll show you in this example. Okay. All right, so we need to draw a dilation of a quadrilateral ABCD with vertices A, B, C, and D. So let's go ahead and plot those points. So plot point A at 2, 1. So go to the right 2, up 1, label that A. B is at 4, 1, label that B. C is at 4, negative 1. So plot that, label it C. D is at 1, negative 1. So plot that, label that D. And then connect to make a quadrilateral. Just for fun, does anybody know what we call that type of quadrilateral? A rhombus. Not a rhombus. Trapezoid. Rhombus would need all the sides the same. It's definitely not. That is a trapezoid because you only have one set of parallel sides. Anyways, we'll get there in chapter 8. Okay, so now we are going to complete a dilation using a scale factor of 2. So if my K is 2, will my shape be getting larger or smaller? Larger, right? So it would be an enlargement. If it was a number less than 1, then it would be a reduction. So because I'm doing a scale factor of 2, my image, there's your symbol, my image of A is going to turn into the double of those coordinates. So doubling 2 makes 4, doubling 1 makes 2. My image of B will be 8, 2.
This is like transition.
Well, it's a transformation, right, yeah. Just like we did in chapter 4. My image of C will be 8, negative 1. And my image of D would be 2, -2. Bless you. So now let's go over to our graph and plot those points and label them.
Isn't 2 times -1 -2?
Yes.
See?
Oh yeah, why did I put 1? Thanks. Change that. Make sure that's 8, -2. Good catch, Kyle. All right, so 4, 2. 1, 2, 3, 4. 1, 2, 3, 4 up 2. Puts A prime there. 8, 2, 4, 5, 6, 7, 8. 2 puts B prime there. 8, -2 gives us C prime. 2, -2 gives me D prime, and then connect. And it's okay that they're overlapping. So we just did an enlargement. If my scale factor was 1/2, what would be the image of A? 1, 1/2,
Oh,
right? Because you're taking half of those. If my scale factor was 1/4, what would be the image of B?
1. Oh, wait. That's
B would turn into 1 and 1/4, right? Okay?
Well, where would you graph 1/4?
Yeah, like right. So like 1 and 1/4, right about there. Just kind of eyeball it. Questions? That's it. Not too complicated.
Another section, did I do?